Hello and welcome to the Bearded Mathman's YouTube channel. Hey, in this video, what we're going to be talking about is how to graph y equals sine of x. This is the first in a three-part series on graphing the basic trig functions, sine, cosine, and tangent. And the idea is that you understand how each of the functions work, and you understand their properties and some of the basics, so that just like as you learned with graphing y equals x squared plus 4x plus 3, you learned all of the basic properties of a parabola, and that allowed you to make graphs quickly and easily, to read and understand graphs quickly and easily, and that's what we're going to do here with trig. Now, before we get into how to graph y equals sine of x, there's some key pieces of information that need to be in the forefront of your mind. You probably already understand them, but it's going to help make the new information make sense so you can better remember it. So the first thing is a graph. Well, a graph is a picture of all of the solutions to an equation, or a picture of all of the possible input and output relationships in a function. And because there are infinitely many inputs and outputs to a function, or, well, for many of these, especially for like trigonometric functions, a graph is a very practical way to display the information. And so what we end up having when we have a graph is, if you have a point like this right here on this graph, 3, 0, this says that, well, if x is 3, if the input is 3, well, then the output is going to be 0. So f of 3 equals 0. On a graph, that would be 3, 0. That's pretty basic stuff. You probably really understand that. The only thing that gets confusing about that is when we start talking about the unit circle. The problem with the unit circle is it's not a graph. It's a diagram that helps us understand some of the basic fundamental ideas in trigonometry. The reason that this is not a graph in the sense that it's a picture of all the solutions to an equation or a function, all the inputs and outputs to a function, is that this coordinate right here is not a solution. What we have is 30 degrees is the input. And if you're talking about cosine, x is the output, and y, if you're talking about sine, is the output. It's not that this x is the input and this y is the output. So it's not like f of the square root of 3 halves is equal to 1 half. That's not what's happening at all. This is a diagram to help us understand that if you're talking about 30 degrees, we can quickly see that the sine of 30 is 1 half and the cosine of 30, square root of 3 over 2. And so what we really are going to be doing when we're graphing trig functions is we are going to be taking all of these angles and placing them on the x-axis, and all of, well, the y coordinates on the unit circle will be sine, and all of the x coordinates on the unit circle, that'll be cosine. And so our x-axis is going to be angles, 2 pi or 360 degrees from 0, and our output, the y, are going to be all of these coordinate values. Once again, y for sine, x for cosine. So let's go ahead and get to that, shall we? Let's start off with a t-chart. When we look at y equals sine of x, once again, x is an angle. It is the input. The output is opposite over hypotenuse. And what we did for this t-chart is we went ahead and took 1 half, wrote it as 0.5, square root of 2 over 2 is 0.707, and the square root of 3 over 2 as 0.866. Those are good approximations. X is input, y is output, so we're going to graph that on a coordinate plane. Now, one of the tricky things, especially if you have to draw the coordinate plane by hand, is not that x is the input, and that's a degree, and y is the sine of x, but what's tricky is the range and the domain. So the range of sine goes from -1 to +1. So we start off at +1, and we're going to cut that in half. We're going to cut it in half again, going negative down to -1. Now, our domain is from 0 to 360 degrees. And that's quite a drastic change from -1 to +1, going from 0 to 360 degrees. So that's why our graph kind of looks stretched like this. So 360 degrees, we put that somewhere off to the right. Now we have to figure out, where do we put all of these other values, like 180, 90, 45, 30, and 60? Well, what we're going to do is we're just going to be cutting it in half. So if this distance was 360, halfway is 180. Cut it in half again. Somewhere over here is 90. Cut the other quarter in half. Well, the other half in half to make quarters. We end up with 270 is going to be halfway between 180 and 360. If you're drawing it by hand, close is good enough. Now, the 45s are halves of 90. So each of these sections, if we cut them in half, we get our multiples of 45. So we get 45, 135, 225, and of course 315. Now, there's two ways to go about doing the remaining angles, which are multiples of 30 and 60, or just multiples of 30. You could think of it that way. You could say from 0 to 90, if you cut that in thirds, you're going to have a 30 and a 60 and a 90. You could also approach it by saying, well, 15 degrees-ish, right, to the left and to the right of 45 is where our 30 and 60 is. And you could do that for each of the multiples of 45 degrees until you end up with a coordinate plane that looks like this. Now, what we're going to do on our coordinate plane is we're going to graph all of these inputs and outputs, x, comma, y. So if we have 0, 0, then it's of course at the origin. 30, 1/2, that's pretty easy. 30 is right here, 1/2's right here, so we're just going to put 30, 1/2 where it belongs. Now, here's where we're going to start to be potentially getting in trouble making an ugly graph. We have to be careful. Square root of 2 over 2, 0.707. That's a little less than 3/4. 3/4 is, of course, exactly halfway between a half and 1. So 0.707 is going to be a little bit lower than 0.75. Now 0.866, it's about it's kind of halfway between 3/4 and 1. It's right about there. And of course 90 degrees and 1. So that's our highest value, 90 degrees, comma 1. Now we just go ahead and put the rest of the points on the graph, same exact way. You've been plotting points probably since sometime in middle school. Boom, we're done. We have the outline of this shape, which is a sine curve. And when you connect the dots, or the x's in this case, you have to make sure you're not making a straight line in between any of the 2 points. It's a curve that's smooth and continuous. It should look something like this diagram right here. Now, let's go ahead and take a look at some of the features of sine so that, well, you don't have to do a t-chart every time. So you can just remember a handful of properties that you can use. And that way, if you see a graph, you can recognize if it's sine, or if you're asked to graph sine, you can do so quickly and efficiently and, of course, correctly. So one thing I want to be sure of is what we have is along the top of the x-axis, we have written these values in degrees, and on the bottom they're in radians. If you're having trouble with radians versus degrees, I'll put a link in the description. You can watch a video, you can read about it, you can practice some stuff. That way you're rock solid, so you won't get confused in trigonometry when you see something like 2 pi over 3, right? All right, now, here's what I want you to see. As the inputs x increase from 0 to 90 degrees, or pi over 2, look what's happening to the outputs. They're increasing from 0 to 1. 1 is our maximum. So we have this point right here, 90, comma 1, or pi over 2 radians, comma 1. Same thing. Now, as x increases from 90 to 180, what ends up happening is the y values start to decrease until they get back to 0, and we have another x-intercept. As x increases from pi to 3 pi over 2, or from 180 to 270, the y values decrease from 0 to -1, and that's our minimum value. To finish it up, as x goes from 270 to 360, the y values increase from -1 back to 0. So what we end up with is we have a maximum value at 1/4 of the period. Now the period is how long that the trig function takes to complete one cycle before it starts to repeat itself. In a minute we'll see a graph where we see multiple periods on the same, but because the x values, the angles, could be negative off to infinity, and they certainly go past 360. Well, in a unit circle, it's easy to see that everything repeats itself, but on a coordinate plane, we usually only draw one period because that gives us enough information to understand what's happening. Anyway, for sine, 1/4 of the way, we have a maximum. 1 or 3/4 of the way, we have our minimum at 270, comma -1. And at the midpoint, we have an x-intercept, and at the beginning and the end, we have an x-intercept. So let's go ahead and really draw out the connection between this unit circle, which is not a graph, it's a diagram, and the graph of y equals the sine of x. So what we end up having is, like, for example, this coordinate right here. On the unit circle, it's 0, comma 1. Well, that's really that cosine of 90 degrees is 0, sine of 90 degrees is 1. And that's why on our graph, if you have 90 degrees, you're at 1. You see? And 180 is for the sine of 180, it's 0, even though on the unit circle it's at -1, 0. 270 is at -1 for sine, and 360 is once again at 0. And so as you go around the circle, do you see how this works? As you go around the circle, this curve would be made, because if you look at the y-coordinates as you go around from 0 degrees to 90, the y-coordinates go from 1/2 to 0.707 to 0.866 to 1. You see, they increase, they get to 90 degrees, which is the maximum, and then they start to decrease from 1 to 0.866 to 0.707 to 1/2 back to 0. Do you see? And it continues as you go all the way around until you get to the end of the circle. So now, let's talk about the key features that you need to remember about sine. We went through all the other stuff so you can really understand, because when you understand, you can remember the key features. So the period is 360 degrees or 2 pi radians. It has a range of -1 to 1. That makes us have an amplitude of just 1. Domain from negative to positive infinity. So that's really how it works right there. So what we have right here is an example of how sine keeps going off to the left to infinity and off to the right to infinity. And what we end up seeing is that this is a cycle. It keeps repeating itself. So if you were to start right here, you would go up, get a maximum, go down, x-intercept, that's halfway through one period, go all the way down to a minimum and back up to another x-intercept, and then it repeats itself. As it repeats itself, those are all different cycles. So one cycle is one period of cosine, or sine is 2 pi or 360 degrees. It turns out it's exactly the same for cosine. So what a period is the distance of x it required to do one cycle, and what amplitude is. The amplitude of sine is 1. What amplitude is the difference between the maximum and the minimum divided by 2. So if the maximum is 1, the minimum is -1, that's a distance of 2. 2 divided by 1 is just 1. So the amplitude of sine, you got it, just 1. The amplitude of cosine is exactly the same, 1. So I hope this video has been helpful. If you would like some more practice or more information on trigonometry, I'll put a link in the description to my website, thebeardedmathman.com. It'll be helpful and useful. Hey, if this has been a useful video for you, hey, give it a thumbs up, share it on social media, subscribe, it's free. What's there to lose? If you have questions, leave them in the comments down below. If you like the video, leave me a comment down below. I'd love to hear from you. Until next time, hope you have a great day.